Today we're going to continue with our logs, and I'm going to teach you about some properties of logs. So let's recall from the other day when we found the values of 6 and 10 in logarithmic form. Remember that 6 was 2.585 and 10 was 2 raised to the 3.322. Well, what if we wanted to multiply 6 times 10? We know we would get 60, but using our exponents and logs, we could take 2 to the 2.585 times 2 to the 3.322. And if you recall your power rules, that meant that we would then add the powers. So that becomes 2 to the 5.907. And if you put that in your calculator, you should get 60. So the reason we're doing this is that the properties of logarithms, since they are the inverse of exponents, we are going to think of our exponent laws when we do our logarithms. So if I have the log of u times v, when I multiply exponents, I add the exponents. So when I multiply the value of logs, it means I can add the two logs. So that means the log base b of u plus the log base b of v. Now likewise, if I took 6 divided by 10, it would be 2 to the 2.585 divided by 2 to the 3.322. And I would get 2 to the 2.585. When I divide, it means I subtract my powers. So then I would get 2 raised to the negative 0.737. And that should be 3/5. So what that means is then, if I'm going to have a log where I divide the values, since with exponents I subtracted the exponents, that's exactly what I will do with the log values. So it becomes log b of u minus log b of v. And likewise, if I would take a power to a power, I would multiply. That means I would do the same with the logs. When I take the value raised to a power, that means that I would multiply the power times the log base v, multiply the power of v times the log of u, since power to power means you multiply. And lastly, since log base 1 equals 0, or log base a of a equals 1, if I take and rewrite this in exponential form, I have my base is b raised to my power is 0 equals my value 1. b is 0 equals 1. That's why I can rewrite it from exponent form to log form. Log base b of 1 equals 0. Or, if I have it in log form, a to the first equals a, which is true. So log a of a equals 1. And where we're going to use this is especially when you see log of base to the same value, we can reduce that out to a 1. So let's go ahead and try some. This says use the calculator to evaluate each and then state the log property that was used. In other words, if I punch in my calculator log 4, I get 6.6021 plus log 7 is 0.8451. So if I add those two up, I get 1.4472. Now that should be equivalent to the log 28. So if you punch log 28 in your calculator, you get 1.4472. So it does prove, again, that the log rules work. So what rule was used to go from log 4 plus log 8 to log 28? That would be the multiplication property. Let's try the next one. 10 log 2. So that's 10 log 2 gives me 3.010 and log of 1024 still gives me 3.010. What rule was used? I don't know if you can see that this was multiplied power to power. So it is the power to power rule or property. Now the next one, natural log of 12 minus natural log of 4. So first find natural log of 12, 2.485, minus natural log of 4, 1.3863. And when we subtract those, we get 1.0987. That should be the same as natural log 3, which is 1.0987. What rule was applied? When do we subtract powers? When we divide. So this is the division property of logs. So whatever you do to exponents, that's the same thing you will do to break up the logs. Because exponents and logs are the exact inverse of each other, so the exact same properties will apply. Alright, let's try some. Let's try just a few at a time. Now without your calculator. This one says log base 5 of 2 times x to the 6th. So when you're going to apply your property, you're going to look back here at the value and what was done to the value. So we are, first of all, multiplying. So let's do the log 5 of 2. And when you multiply powers or logs, it would mean you do what to the exponents? You would add, so we're going to add the log. So add log 5 of x to the 6th. Well, in this case, I have log of a value, but here I have a power yet. So that one I have to expand further. So this one I'm just going to drag along. Log base 5 of 2 plus power to power means I bring it to the front and multiply. 6 times the log of base 5 to the x. Now I just have values on my logs. Now let's try the next one. Log base 7 of y divided by 3x squared. So I heard the divide by. So when I divide powers, it means I subtract them. So I'll do the same to logs. So it's log base 7 of y minus log base 7 of 3x squared. Here's just my value y. Here's my value 3x squared. That's 3 times x and the power square. So this backlog, I have to expand some more. So that becomes log base 7 of y minus, and we're going to subtract, this is one quantity, so we have to put it in parentheses, log base 7 of 3 times means plus log base 7 of x squared. Which, let me move these. Means log base 7 of y minus log base 7 of 3 minus, and this power has to come to the front of this log, so that means 2 log base 7 of x. Okay, let's try this one. Expand log base 3 of 9 times 27. Well, what that means, I hear times back here in my value, so that means I'm going to add my logs. So it is log base 3 of 9 plus log base 3 of 27. Now, can you write 9 as a base 3? That would be 3 squared, so that becomes log base 3 of 3 squared. And can you write 27 as a base 3? That's log base 3 of 3 cubed. Well, back here I have a power, so I have to move those to the front. So that becomes 2 times log base 3 of 3 plus 3 times log base 3 of 3. And we just learned that anytime you have log base of a value that are the same, we can replace this with 1. So this is actually 2 times 1 is 2, plus 3 times 1 is 3, is actually equivalent to 5. That means log base 3 of 9 times 27 equals an exponent of 5. 3 to the 5th will equal 9 times 27. Okay, let's try these couple that we got here. Okay. Log of 1,000 squared. First of all, what's my base here? Without any base, it's just a 10. That's my common log. So this is my power, which moves to the front. 2 times log base 10 of 1,000. Well, can you write 1,000 as a base 10? That would be 2 times log base 10 of 10 cubed. Which again, I have a power that needs to move to the front and multiply. So that becomes 3 times 2 times log base 10 of 10. Log base 10 of 10 replaces with 1, and it becomes 3 times 2 times 1, which is 6. When you have natural log, what's your base? E. So here's my power of 5, which will move to the front. So I have 5 natural log E of E. And anytime I have the same base and value, this replaces with a 1. So 5 times 1 is 5. All right. Now we're told that log base 9 of 5 is approximately 0.732. Log base 9 of 11 is approximately 1.091. So what we're going to do is expand our logs so that we can either get them down to a log base 9 of 5 or a log base 9 of 11. Because then we can replace those values with the decimal value and evaluate from there. So if I'm expanding log base 9 of 5/11, that's dividing. So my rule or property would be to subtract log base 9 of 5 minus log base 9 of 11. Well, log base 9 of 5 is 0.732, so I can replace that right here, minus log base 9 of 11, which is 1.091, so I can now replace this with 1.091. And 0.732 minus 1.091 is negative 0.359. So the log base 9 of 5/11 is negative 3.59, which means 9 to the power of negative 0.359 is 5/11. Okay, let's try the next one. Log base 9 of 55. Remember that we want to write it in log base 9 of 5 and log base 9 of 11. So can we write the 55 as values of 5 and 11? 5 times 11. So we would write log base 9 of 5 times 11. And when I multiply, that means I add. So log base 9 of 5 plus log base 9 of 11. Log base 9 of 5, 0.732, plus log base 9 of 11, 1.091, is 1.823. And the last one, log base 9 of 25. So I will need to write 25 as values of 5 or 11. And log base 9 of 5 squared. So then again, I have my power that will move to the front. So that is 2 times log base 9 of 5. So that is 2 times, I can replace that with 0.732, which is 1.464. Now we're going to go the other way. All of this before was expanding. Now we're going to take the expanded logs and write it back down, condense it down to just one log. So when I look at this, I first look what log I'm writing it as. So it's all going to be written as log base 3. And then I have to think about my rules. If it was 2 times, I'm going backwards. That meant this had to be a power. So it's log base 3 of 7 squared. Minus means to divide by, here again I got a power, x to the 5th, which can be simplified to log base 3 of 49 over x to the 5th. There's my value. Let's try the next one. What log are we going to write them all as? Log base 8. So again, here's a power. So it becomes log base 8 of x squared. Minus means divide. No power in front, so 5 minus still means divide. Well, here's my divide bar. This is a power of y squared, or excuse me, y cubed. And nothing can be evaluated further. Log base 8 of x squared divided by 5y cubed. All right, this one's just a little trickier. Still, look for what your log is going to be. It's going to be log base 3. So, log base 3. Okay, now, notice that this one has no log value on it. Oh, I want that to be a different color. So I have to write that in base 3. Now we need to think for a moment. If there is no log on it, that meant in log terms, that was the exponent, because all logs equal the exponent. So if this was the exponent of 2, what base did it come from? Our base was 3. So this would be 3 of that exponent 2. Plus means times, and this value back here is x, which gives me log base 3 of 9x. Because if we go backwards and we think about it, if we had to do log 3 of 3 squared, the 2 would come to the front. So we would have log base 3 of 3 squared, the 2 would come to the front. And log 3 of 3 is 1. 2 times 1 is 2. And that's how I got that value all alone. Okay, let's try the next one. What log are you going to write it in? It says log 5. So it is log 5 of what value? My 2 is my power, so that becomes x squared minus means to divide, and then I have my value alone. I have to put that into log 5. So my base is 5 and the exponent was 3. So this becomes log 5 of x squared divided by 125. And again, you could work backwards. The 3 would come to the front, and log 5 would be 1 times the 3 would leave the 3 standing alone. Okay, why do we even study logs? Well, the purpose is because not all bases can be written as the same base to an exponent. So that's how come we use logs, so that we can evaluate it when we have different bases. And the author of this book does refer to it as a change of base. But all change of base means is that you will apply your definition of what logarithms are. Remember that a log base b of y equals x. That means the base was b, the power was x, and the value was y. So b to the x equals y. So let's just rewrite this like we did in the very beginning. Log 5, 9. Rewrite it in exponential form. So that becomes base 5. Alright, let's go back here a sec. Do you know what log base 5 of 9 is equivalent to? No, so we're going to call it x. So it's base 5 raised to the x equals 9. Can you ever get 5 and 9 to be the same base? No. So this is where we can now log both sides. So here's my exponent, which comes to the front, and I have x times log 5 equals log 9. So if I'm solving for x, because I want what value it is, I divide by log 5. Okay. And when I'm going to see these, I'm going to want to see this math done, because now it is calculator ready to be punched. So I always want to see all the math, and then you can punch your calculator. So x would equal log 9, and make sure you close off that parenthesis, divided by log 5. And you should get approximately 1.3652. Okay, let's try log 6 of 15. Do you know what its value is? No? So then we're going to say it equals x. So my base is 6, to my exponent of x should equal my value of 15. Can you ever get 6 and 15 to be the same base? So then we must log both sides. So again, my exponent is x, so I bring that to the front. X times log 6 equals log 15. So to solve for x, I divide by log 6. Now it is calculator ready. So log 15 divide by log 6. 1.5114 approximately. Alright, well that looks like it. You should now be able to spend the rest of the time practicing on your homework, and I do suggest that you do spend some time working on some of your problems. And I'll try to clear up any questions you have tomorrow when I come back.